Up to this point, you've been following picture-based wiring diagrams. That's perfect for getting started, but if you ever look up a circuit online or collaborate with other engineers, you'll notice something different. They use something called a circuit diagram, also known as a schematic. This is the universal language of electronics. So today, we're going to learn how to read, understand, and even draw circuit diagrams, so you can start thinking like an engineer. Here's the schematic version of the exact circuit you just built in your lab. Let's walk through it piece by piece. These two symbols represent a battery. The longer line represents the positive terminal, and the shorter line represents the negative terminal. This is your power source, and it pushes voltage through the circuit. The black lines represent wires. They connect all the components carrying current. Wires don't affect how the circuit behaves unless they're extremely thin or long. This zigzag represents a resistor, which slows down current. Above it, you'll usually see a value like 1k ohm, which means 1000 ohms of resistance. This is a light emitting diode. The arrow shows the direction of conventional current flow from positive to negative. The key idea here is electricity needs a complete path or closed circuit to flow. If there's a gap anywhere, the current stops and the LED won't light. Let's talk about something essential in circuit diagrams. Ground, also written as capital GND. What is ground? Ground is the reference point for measuring voltage. We usually assign it a value of 0 volts, like the literal ground we stand on. In most circuits, the negative terminal of the battery is used as ground or called ground. Why does ground matter? Because voltage is always relative. It's the difference in electric potential energy between 2 points. If ground is at 0 volts and your battery is 9 volts, then we just say that the positive terminal is plus 9 volts. It makes understanding it a lot simpler. Think of voltage like a waterfall. The top of the waterfall is the battery's positive terminal, which is high potential. The bottom is ground, which we say is the negative terminal of the battery and is low potential, or 0 volts. Water flows from high to low, just like electric current. The higher we are from the ground, the more energy we have to use. The key takeaway here is voltage is a difference. There's no such thing as voltage at a singular point. It's always from one place to another. That's why things typically have 2 wires and why batteries have 2 leads. Let's talk about current direction. In conventional current flow, current moves from higher potential to lower potential, from plus to minus, just like water flowing downhill. To understand this better, we need to talk about polarity. Polarity means that something has a positive side and a negative side. This tells us which way current is supposed to move. Some components, like LEDs and batteries, care about polarity. They're very fussy. If you connect them the wrong way, they won't work, or they could even get damaged. So with that in mind, let's assign polarity to our components. Let's start off with our battery. We start from the positive terminal, giving us a positive polarity since we start at a higher potential. For the resistor, the side current enters is at a higher voltage. The side it exits is at a lower voltage, and we know that because resistors eat up or use up that energy. Now, let's talk about polarity in the LED. The anode, or the long leg, connects to the higher voltage side. The cathode, or the short leg, connects to the lower voltage or ground. If you flip the LED backwards, it won't light up. And that's because it only allows current to flow one way. And finally, we reach the negative terminal of our battery. Cool. Now that we have done the polarity, let's trace the voltage in our circuit. Let's walk through it and see how the voltage behaves or changes in the circuit you just built. Step 1. Current starts at the battery's positive terminal at 6 volts. Then it travels through the wire, still at 6 volts. It then passes through the resistor. And let's say the voltage drops from 6 volts 2, 3 volts. Then it reaches the LED, another voltage drop. Current returns to the battery at ground, meaning 0 volts, and then it goes up the positive terminal of the battery and regains energy back to 6 volts. This keeps looping over and over and over again, and now we know the loop is complete. Okay, so what if we remove the LED or a wire? The circuit is broken, current can't flow, and the LED, dark. The key takeaway here is a circuit must be closed for electricity to flow. Okay, let's summarize. Circuit diagrams are the universal language of electronics. From here on out, we'll be expressing circuits using circuit diagrams, not pictures. As we move forward, keep a few ideas in mind. Voltage is the difference in energy between 2 points. Current flows from high potential to low potential, from positive to negative. Ground is our 0 volt reference point that everything else is measured against. Some components, like LEDs, have polarity. This means they must be connected the correct way for current to flow properly, positive to negative. Resistors, on the other hand, do not have polarity. You can connect them either way. And most importantly, a circuit must be closed, a complete loop for electricity to flow. No closed path, no current. Finally, I made you a sheet with a collection of common circuit elements. Don't worry if you don't recognize all of them yet. We'll cover each one as we go along. Here's a challenge if you're up for it. Look up a simple circuit online, maybe with a switch, battery, and a light bulb. Try to identify each symbol and trace the current. Then draw your own schematic based on what you've learned. In our next session, we'll take this one step further. We're going to dive into circuit analysis, the math behind the magic. You'll learn how to calculate voltage, current, and resistance, and finally, start solving real electrical problems. Can't wait to see you there. If you like what you've seen so far, you should visit our website and check out our electronics and coding kit. It comes with all the videos, all the lessons, all the code, all the labs, and all the project files. So yeah, link in the description and happy learning.